Hey everyone, in this short video, I'll show you how to construct confidence intervals for a sample mean using Google Spreadsheets. First, the first step is given any situations or any samples, we need to verify whether either the normal distributions, the Z distributions, or the T distributions can be used. As a reminder, Z distributions is a normal distribution, and T distributions is sometimes called the student distribution. Well, in order to verify this piece of information, we need to look at the sample size and the distributions of the populations. So at the sample size, you're going to ask whether the sample size is at least 30 or not. And in the population distribution, you're going to ask yourself whether the distribution is a bell shape or not. So this table here will show you 4 cases. The first case is yes, yes for the bell-shaped distributions and the sample size. And this case is a yes, no, which means the population is normally distributed, but the sample size is less than 30. This case is an example of the population is not normally distributed, but the sample size is at least 30. And this case is showing you the case when neither the population is normally distributed or the sample size is at least 30. So if you run into one of the 3 blue cases, that means you can either use the Z distribution or the T distribution, which is one of the 2, and we will discuss on which one to use a little later. But if you run into the case where the population is neither normally distributed or the sample size is not at least 30, then you cannot use either the normal distribution, the Z table, or the T table to construct confidence interval for a sample mean. All right. So the step 2 is once you verify whether Z or T can be used, then you have to look at whether the population's standard deviation is known or unknown in order to decide which distribution you're going to use. So the answer is if the population standard deviation is known, then you can use Z-score or the Z distributions or the normal or standard normal distributions. If the population standard deviation is unknown, then you have to use a T distributions. Again, this is a step is followed by the first step. So you have to verify whether Z or T can be used before running to the second step. And the third step is actually construct or calculate the confidence intervals. And I will illustrate the 2 cases. The first case is you're going to use Z distributions, and the second case is you're going to use T distribution. In either of the cases, if you get a sample, then you should have a sample mean. And if the population standard deviation is available, then you use the population standard deviations. The sample standard deviation can always be calculated, but it's not be used in this case. You have N, which is a sample size, and you have alpha level and the confidence level, right? Which is if the alpha level is 0.05, then the confidence level is 0.95, which is 1 minus 0.05. So from this, all this information, you can construct the margin of error using the functions. Confidence, just say confidence interval for normal distributions. This is the function that we're going to use because we're using the T, the Z values, and because the population standard deviation is known. So in this case, in order to use confidence intervals, you want to verify, you want to input alpha level and then standard deviation, the population standard deviation, and the population size. So these are the 3 pieces of information that you need to put in these functions, and that will give you the margin of error. So the margin of error is the maximum width from the population mean to the lower bound or upper bound of the confidence interval. So using the margin of error, you can construct the lower bound by subtract the margin of error from the mean. So the sample mean minus margin of error. And you can calculate the upper bound using the mean and add to the margin of error. Okay, so we found margin of error first, and then we can find the lower bound and the upper bound of the confidence intervals for this sample, given this population standard deviation. Now for the t distributions, again, you have pretty much all the same pieces of informations compared to the z distributions, except the population standard deviation is unknown in this case. So that's why you have to use t distribution. And then the sample standard deviation is used in this case because this is the only standard deviation that we know. Sample means, alpha level again 0.05, confidence level again 0.95. It depends on the examples, depending on the scenario, alpha level will be changed and confidence level will be changed accordingly. So again, construct a margin error for t distributions. You're going to use confidence intervals, but the t dot t. The confidence interval for the students' t distributions. And again, you are asking to prompt the similar pieces of informations, alpha, standard deviation. In this case, it's a sample standard deviations and the sample size, which is this size, right? Here's a margin of error, and you can calculate the lower bound using the sample mean minus the margin of error, and you can calculate the upper bound using the sample mean plus the margin of error. All right, so we learned how to construct confidence intervals for using two examples. First examples, using the z distributions or the standard normal distribution to construct margin of error and then lower bound, upper bound. In the second examples, you use t distributions. It's because the population standard deviation is unknown. So then we have to use t distributions, we constructed margin of error and also lower bound, upper bound. And the last step is interpret the result interpretations. There's a technical interpretations that you want to pay attention to is, what does it mean when you have alpha level of 0.05 or the confidence level of 0.95? It means if you collect 100 samples and you construct 100 confidence levels, intervals, then about 95%, about 95 confidence intervals contain the population mean, and about 9 confidence intervals will miss the population mean. And if you want to interpret this result, in terms of a little more novels or literature interpretations, then you can say with a 95% confidence, the population means is in between, the lower bound and the upper bound. You just constructed confidence intervals, and you have 95% confidence that you will capture the population mean in between 26 and 29 for the first example. And you do the same interpretation for any of the examples that you're running into this scenario when you have to construct confidence intervals. All right, so again, this video will show you how to determine whether you can use either z or t distributions to construct confidence interval given your scenarios, right? And second, using population standard deviations to determine whether you're using z or t. And third is calculate confidence intervals in both cases using the functions confidence and confidence.t. Also, once you construct margin of error, you can calculate the confidence intervals using the mean of the sample. And interpretations is, just with the percentage of confidence the population mean is in between the lower bound and the upper bound. And if you have a specific context in which you want to make an interpretations about, then you want to put that context, right? You're going to replace the population mean by the mean of the by the statistics in that specific context, which is, for example, the average commute time, the average spending, and so on and so forth, will be in between the lower bound units and the upper bound with the corresponding units.